So the other method that I will share with you to calculate the formal charge is using this formula that we talked about, HONC 120, 1, 2, 3, 4. Now, I'm going to preface this by saying that it is going to help you, but it's not a magical formula. There are some things that have to come from your understanding. Like when we get to carbon, this method, you may have to remember something else, but nevertheless, it's helpful. So notice in this table right here, that the number of bonds needed for the carbon to be neutral is 4. For nitrogen, it has to be 3. For oxygen, it has to be 2. And you compensate anytime the bonds, okay, you only have 2 bonds, and you have to compensate with lone pairs. All right. Now, in order for you to determine the formal charge, let's say on oxygen, we're going to leave the hydrogen and the halogens for later because, or may not because you rarely actually examine them, is the following. Oxygen, if it has a bonding, more bonding than 2, so that would be 3, okay, the formal charge will be plus. And if nitrogen is above 3, the formal charge will also be plus. Now, when the number of bonds is less, so you have 1 for oxygen, then the formal charge will be minus. And when it's 2 for nitrogens, the formal charge will also be minus. Also, when it's less for carbon, it's going to be minus. However, and this is what I was trying to warn you about. If you look at carbon here, okay, if you look at carbon can have 3 bonds, but with a positive charge as well. It can also have 3 bonds with a negative charge. Well, what's the difference? Look at them, examine them. What is the difference between them? The difference is it has lone pairs on this one, and this one has none. So you need to remember that for all of these, for the oxygen and the nitrogen, is anytime you lose a bond, you have to compensate with lone pairs, just like here. And that has to apply to the carbons. So for carbon, if it has 3 bonds, plus here lone pair, then it's going to be a negative for carbon. But if it has 3 bonds, but no lone pair, then it will be positive. So be aware of that, and we're going to apply it to the next molecule, and you're going to see how this will work very, very nicely. Also, by the way, just to mention, is that some students may choose, I've seen it before, to memorize this whole table. It's up to you. But let's look at this. How to find the formal charge. It says assign formal charges to any atoms that are charged in the molecule. Okay. So we have to remember this. It's going to help you. And using it, we can tell which ones will be charged. So, number 1, H, does it have 1 bond? Yep, they all have 1 bond each. Good. C, I'm jumping to C. Does it have 4 bonds? Yep, C has 4 bonds. Here's 1, 2, 3, 4, and this one has 4 bonds as well. Now, what about the N? Does N have 3 bonds? Nope. N does not have 3 bonds. In this case, it has 4. Okay. So let me erase this so we can have. So what did we say from using this rule? That if the number is over this, For nitrogen, it will be a positive. So here it is. Okay. And now let's look at oxygen. Does oxygen have two bonds? Nope. It has one only. So we write a 1 down here. This oxygen. I'll get to that one in a second. There should be lone pairs on here. But in the future, you're actually going to have to remember that they are there. I know in this case they are not, but I am putting in here. So no, doesn't have two bonds. It has only one. So in this case, for oxygen, remember what we said is that it's going to be a negative if it has less. So here it is. Now, even if there was no lone pair on here, two lone pairs, you recall that oxygen has to have two bonds in order for it to be neutral. So it's kind of implied, but it is, the lone pairs are not drawn. But they will be drawn for these kind of structures and exercises in the future. However, we will get to a point with skeletal structure where they're not going to be drawn.